Okay, hi guys. I'm on week 9, task 2, and you got this worksheet, mold to mold calculations, worksheet 1. So I'm going to do a few of these examples. There's only 6 questions. I'm actually going to do 3, one of each type, just so you can see, you know, how these just increase with difficulty as we get down the page. So I'll do 1, 2, 3. Or sorry, 1, 4, 5, or whatever. I'll figure it out. Okay, number 1. Let's look. How many moles of potassium oxide, which is K2O, will be formed when 1.52 moles of potassium reacts with oxygen, oxygen, according to the following reaction. And so in this one, they've given you the reaction. This is what makes it the simplest start type. So they've given us a balanced equation. 4K plus O2 yields 2K2O. So that is a balanced reaction. This is all given to you in the question. So this is easy. I didn't have to write my equation. I didn't have to balance my equation. I just do my moles. So my known, they told us, was 1.52 moles of potassium, 1.52 moles of K, and how many moles of K2O? So my unknown is moles of K2O. Okay? My known and my unknown. Awesome. This one's a little bit easier. It's pretty quick. So how do I always start stoichiometry problems? With my known over 1. 1.52 moles of K over 1. Okay? That's awesome. What do I put here? Top and bottom bunk. What am I trying to get rid of? What do I do? Well, I'm trying to get rid of moles of potassium. So I'm going to put that on the bottom. And I want moles of K2O because that's my unknown and I need it on the top bunk. Moles of K2O. So now I just got to figure out what numbers go there. Well, I can use my balanced equation to figure this out. So moles of K, I have 4 moles of K. I'm allowed to say that from this balanced equation. I'm allowed to interpret that as a conversion factor. That's part of the laws, one of these laws of chemistry. And so 4 moles of potassium, I get the 4 from this number here in the balanced equation. The other conversion factor to that is how many moles of K2O? Well, I have a 2 out front. 2 moles of K2O, sorry. My units, moles of potassium, get to cancel. Awesome. Now I'm just left with easy math. So this is how I do this math. 1.52, I'll put my calculator up here, times 2, and then I hit equals. So I've multiplied the top, I've hit equals, now I divide the bottom. I could go divide it by 1, but I don't have to because it's the same thing. And then I divide it by 4, equals. So my answer is 0.76. Okay? And is it donuts? No, it's moles of K2O. That, my friends, is the answer. So this is number 1. Number 2 is exactly the same. They've given you the balanced equation. So practice that. Okay? Let's do another one. Let's look at number 3 on this sheet. How many moles of sodium are needed to react with sulfuric acid I don't want to write it all down because I'm a little bit lazy, to produce, and you all have it in front of you, 3.75 moles of sodium sulfate. I'm just going to write this, sodium sulfate, because it's easier, in the following unbalanced reaction. So then they gave us this. Sodium plus sulfuric acid, which is H2SO4, they gave you all this, yields, what is it? It's single replacement. Na2SO4 plus hydrogen got the boot, and he's a 2. Okay? They gave you this on the sheet. This was given. So all we have to do is balance it, and then we'll do our known and unknown and stuff like that. So this is a little bit harder in that here's the balanced, or a formula, but at least they gave you, what is sulfuric acid, what is sodium, the single replacement reaction. They gave you all this. So let's go back and forth and have a look. I have 2 sodium, 1 here, 2 here, so I'll put a 2 here. 2 H's here, 2 H's here, 1 SO4, 1 SO4. That's pretty easy balancing, okay? So I'm done balancing. So now I do my problem. What's my known? They gave it to me, 3.75 moles of sodium sulfate, Na2SO4, okay? And then they gave us the unknown. What did they ask for? How many moles of sodium? Moles of Na, sodium. They've given us and our unknown. How do I start my problem? Same as every single time. 3.75 moles of Na2SO4 over 1. What conversion factor do I use? Well, I use my balanced equation. I use the coefficients out front to give me the number of moles. Who do I want to get rid of? I put on the bottom, right? I got to cancel out moles of Na2SO4, right? What am I trying to find? Moles of sodium. So my unknown goes on the bottom. I get to cancel that out. Oh, wait, I forgot to put my numbers in. Sorry. How many moles of Na2SO4 are there in this equation? There's 1 right here. These, when they're not filled in, are 1s. How many moles of sodium? There was 2. So I got to cancel my units. Awesome. Look, I've got 1s on the bottom. That's easy. The math is easy. 3.75 times 2. 7.5. Is it donuts? Nope. It's moles of sodium. Okay? That's our answer. So now you can do number 4, which is exactly the same. You have to balance the equation first, but they've given you the equation. So that's pretty lucky. Balance it, put your known over your unknown, figure out your conversion factor based on your coefficients in front, and go from there. So practice number 4. You have the answer key, so you'll be able to see it yourself. And then the last one I'm going to do is number 5. I'll do number 5. So you were given a question. How many moles of oxygen are produced when 5.12 moles of magnesium chlorate, CHLORATE, decomposes into magnesium chloride plus oxygen? Question mark. Woof, that's a doozy. All right. So how do I start this? Well, I got to write out I have to write out the equation. You can start by writing out the words if that helps you. So they told us magnesium chlorate decomposed. It broke apart into magnesium chloride plus oxygen. So now we got to have a little scrap down here. Can you guys see down here? No, not really. I'll just straighten this out. Did I? There. So scrap. Down here, magnesium chlorate. What do I do with that? Well, let's look it up. Magnesium, periodic table, Mg plus 2, chlorate. You get your polyatomic. Chlorate, ClO3 minus 1. Crisscross. We get Mg, open a bracket, ClO3, close the bracket, 2. So that's magnesium chlorate. So I'm going to write that here. Open a bracket, ClO3, close the bracket, 2. And then it breaks down into magnesium chloride. Well, magnesium's plus 2. Chloride, you know, you can look up on the periodic table. Right here. It's minus 1. Crisscross, you get MgCl2. So we know we get MgCl2 plus oxygen is said. Well, oxygen alone, whenever you have a single element, you got to look, is it one of my super 7? It is. So he's diatomic. This is a lot of things to remember. I'll put blanks out front. There's a lot of things to remember. All right, let's look at this. Let's balance it. 1 magnesium, 1 magnesium. That was good. 1 chlorine, 2 chlorines. Or sorry, 2. 2 times, there, it's inside the bracket, sorry. 2 chlorine, 2 chlorine. Awesome. 2 times 3 is 6. Oxygen, only have 2 here. If I put a 3 here, we're balanced. Awesome. I'm going to move this up a bit. And I'm actually just going to cover the scrap work so I have a bit of room to do out the rest. Okay, what's my known? They gave to me in the question. 5.12 moles. Magnesium chloride, MgCl2. How many moles of oxygen? And the unknown is moles of O2. That's our unknown. Our produced when 5.12 moles of magnesium chlorate. Oh, sorry, magnesium chlorate. ClO3, bracket 2. So, it gave us moles of magnesium chlorate, and our unknown is moles of oxygen. All right, let's roll with this. So I've got, how do I start? Every time, I put my known over 1. 5.12 moles MgClO3, close bracket, 2 over 1. What goes on the bottom of my second bunk bed? I'm trying to get rid of it. I'm trying to get rid of moles of MgClO3. ClO3 bracket 2. Well, how many are there in the balanced equation? Well, these are 1s if they're left blank. It's a 1. And what's my unknown? Moles of oxygen. So that has to go up here. And how many of those are in this? 3. So here, my moles of magnesium chlorate get to cancel with this guy. Only thing I'm left with is this. 5.12 times 3. 15.36 donuts. Nope. Moles of O2. That, my friends, is our answer. On the answer sheet, they rounded up to 15.4. That's fine. Okay? So, that is how you do. Now you can go ahead and do number 6, which gives you the word problem that you then have to solve into an equation. Then you have to balance it. Then you do the math. So, number 6 is the hardest on the sheet, but you've got it. You just saw me do number 5. And you've got the answer key to look at it once you've practiced. Okay, that's it for today. Zip me an email if you need me and do a one-on-one. Okay, thanks, bye.